We just finished talking about the data that's going into these data structures. And now it's time to focus on the actual data structures. This is the Savage Scientist Ed, governor of the state of Swampland. Today, I'm gonna be finishing up this video on data structures. Stand by, this video is about to start. This is the Savage Scientist Ed right here. And I'm Uber in a police car. Alright, so I made a promise back sometime last year, just saying that, just asking all my citizens of the state of Swampland, or people subscribe to my channel, what type of content they want to see here. And a lot of people say computer science and Uber related stuff. So to keep to that promise, I'm starting to talk more about computer science. You want a computer science, so here it is. So the first data structure we're going to talk about is the array. An array is a simple collection of continuous blocks of memory that's going to hold similar data types. So in these arrays, we're only going to have either all integers, all characters, or all Boolean, or all float, whatever. It's going to be all the same data type. So no mixing stuff. You can't have an array that's going to have a computational number in the middle of it. So let's go into some examples. So I just created a character of an array with 6 characters, and I'm gonna call it A1. And this is the contents of A1. It's the letter S, the letter A, and the letter V, and the letter A, and a G, and an E. All those are characters. This word is savage. And I created another character array that's going to have a length of 3, meaning 3 elements is going to be in an array called A2, and that's going to hold a 3, a 7, and an 8. And then I created another array of integer values. So that's going to be 2 integer values called A3. A3 is going to contain the number 273. This is a number. That means this number could be incremented, decremented, divided, subtracted, added, done anything mathematically possible to this number, 273. And the second one is 901. So this is A3 value 1, A3 value 2. And that's why it is written like this, integer subscript 2. And if you have 2 gigs of memory, it's going to be much bigger than this. But to keep things simple, this is what this is looking like in memory. We have Savage, the S in Savage posted right here. AVAGE right there. So this is called A1 0, A1 1, A1 2, A1 3, A1 4, and A1 5. So if I wanted to change this to a C right here, it would look something like this. A1 0 1 2 3 4 value 4 equals C. So that's how you would actually address each one. So like I said, A1 5 would be the E, A1 0 would be the S. So if I change that to a R, we're going to have Ravik, and I also changed that to a C. Ravik Kai, Ravik Key, whatever the hell this new word is I just created. That was just created by changing A1 4 to C, A1 0 to R. So we also could do the same with A2. A2 is 378, and that's what it looked like. This is 0 1 2. And we also have A3 that has the value 273 901. So I could do something like this. A3, this is a subscript 3, 1 equals 40 divided by 2. So right here, this value has been changed to 40 and then divided by 2. So this is now 20. This was mathematically computed by this formula or this function. So I also could go back and change it back to 273 by just addressing it. Oh, and this also should have been a 0. A1 0 equals 273. So catch this mistake that I just made. This is because I actually changed this value 901 by saying 1, because this is 0, this is 1. In computer science, we start off with 0. So in this array, value 0 has 203, value 1 has 901. So remember that. Don't make that mistake. And if you see any mistakes in my videos, point them out to me. So we have a 20, but right here I just changed that to 273. So now it's back to 273. So A3 has 273 and 901. And we haven't talked about this 378 too much. This is the numbers. The number 3, which is a symbol, the number 7, and the number 8. I could put a N right here in the middle of this. So now it's 3 and 8. And how to do that? I would just say A2 1 equals the letter N. Now I can't do something like this. A2 2, so I'm pointing to the 8. I'm talking about this 8. I can't say something like this. 8 minus 7. This will not compute because this is the symbol 8. This doesn't have any computational value. I can't add, subtract, multiply, divide, do any of that stuff to this 8 because there's a character 8. And remember, characters are just symbols. When you look at A3, those are integer values, so they could be added and subtracted. You can have large values in here. You can have the number 9,372 in here if I want. Actually, I'm about to do that. I'm about to change A3 value 1 equal 9,720. So now this is 9,720. Because I just declared it right here. I mean, I just set this value. Declare mean these are declaration statements where in computer science we declared a character of 6 elements to be named A1 and has the word savage. This is just a statement to change the value in this declaration. And when I get me some nano leaves, you'll be able to see this a lot better. So let me come over this way. So now you see A1 has the value 9,720. And there it is. All this is in this array. Damn, this took a long time. So let's move into the second data structures, the list.